Okay, today we're going to do a quick lesson on one-step equations. And in these type of equations, we will only be using addition or subtraction. So in algebra, we can solve for an unknown value by using variables to represent an unknown amount. Variables are lowercase letters of the alphabet. A lot of the times we use X and Y in math, but honestly, you can use any letter in the alphabet as a variable. So here we have our first example, and we have a one-step equation. That means it'll only take us one step to actually get an answer. X is representing the variable. We are adding 5 to that, and that equals 14. Now I know a lot of you are like, oh, I can use mental math, and I know that that number is 9. But in algebra, we want to begin using algebraic equations to solve for a missing value, because they're not always going to be this simple. So let's take a look at that example, or a couple of different examples, and learn how to use algebra to solve for a missing amount. So up here you can see that in order to solve equations, we actually have to perform the opposite operation in each of the following problems in order to come up with our answer. Now I call that balancing equations. And I give you kind of an example in real life of what that's like. Many of you have probably worked out in a gym, or you've seen weightlifters lifting pretty heavy weights using a barbell. Well, when they do that, they always put the same weight on each side of the barbell to make sure it's balanced. We do the same thing when we balance equations. So we need to make sure that we add or subtract the same value from both sides of the equation. So let's take a look. In example 1, x is our variable, and we are subtracting 3 from that amount to get 2. So when I say we're going to do the opposite operation, right here my variable is x, and I am subtracting 3 from that x. Well, the opposite of subtraction is addition. So I want to actually add 3 to the left side of the equation and add 3 to the right side of the equation. So this equal sign actually separates our equation into the left side, which is just x minus 3, and the right side, which is just 2. So just like a weightlifter might have like a barbell like this, and if they add 3 pounds to the left side, they're going to add 3 pounds to the right side, so that when they lift this barbell, they're not lifting it so that it's unbalanced. So basically that's what I mean when I say that we are going to balance our account, or our equation. So let me get rid of that and go back to the problem. So once we decide what we need to add on both sides, and basically that's right here, we're just doing the opposite of subtracting 3, we're going to add 3. I'm just going to draw a line here now so that I can add straight down. Now the x is staying put. Negative 3 plus a positive 3 equals 0. So these are going to cancel each other out. I'm going to leave the equal sign there, and I'm just going to add straight down 2 plus 3 and get 5. So that means the answer to our one-step equation is 5. Now a lot of you probably knew that. You knew that 5 take away 3 is 2, but this is how to show your work using algebra. So let's try another example, and really the only way you're going to get better at this is just by practicing. So it does take a while, so try not to get frustrated. So in this problem, here's our variable right here. It's always easy to spot that variable because it's always a letter from the alphabet. We are adding 3 to that variable, and we're to get 5. Well, I know that that's 2 because 2 plus 3 is 5. Using your mental math to kind of check your algebra skills is actually a great idea. So if I am adding 3 to x and I want to do the opposite operation, the opposite of adding is to subtract. So this time, instead of adding 3 more, because I want to do the opposite here, I'm going to subtract 3 from the left side of my equation, and I'm going to subtract 3 from the right side. I drew this line here again because it's always separating the left side from the right side right at the equal sign. If I draw my line, and I'm going to add straight down again, I'm not adding anything to x, so it's staying there. Positive 3 take away 3 is 0, so these two cancel out, and I'm left with nothing. Equals 5 take away 3 is 2. So just like we said, we knew we would end up with the answer 2, but showing all of our work using our algebra skills, it's all right there. Okay, so let's take a look then at the next screen, where we're going to do a couple more examples. So notice that I have used the variable x a lot, and it's not always used. I could have used any letter here, but I like x because we know for sure that that's a variable, and we're not confusing it with a number. X subtract 6 equals 3. So in other words, some number take away 6 will give us 3. Some of you are probably sitting there going, oh, I know what that answer is. Well, let's see if you are correct. Let's, instead of subtracting 6, we want to do the opposite, which would be to add 6. So I'm going to add 6 to the left side, and this separates our equation into two parts, and I'm going to add 6 to the right side. So we're balancing our equation. I'm going to draw my line again. X is going to remain there. Negative 6 plus 6 equals 0. So I'm going to come down here and leave my equal sign right where it was. 3 plus 6 is 9. So if you were thinking in your head mentally that the answer was 9, you are absolutely correct. Now we can always check our answer by taking our 9 and filling it back in here for x and confirming that 9 minus 6 is in fact 3, and that is true. So that's just kind of checking your answer, and we definitely do that a lot in Algebra 2. Here's example 4. Now in this example, notice that my answer is right here, my equal sign, and my x minus 12 just happens to be on the right side instead of the left side like it was over here. You don't need to change anything. Could I rearrange this and put x minus 12 equals 4? Sure. But I'm going to leave it just like it is because I don't like to waste any time. So I know that here's my variable. I'm taking away 12 from it, so I want to do the opposite. Instead of subtracting 12, I want to add 12 on both sides. So I'm going to put that in on both sides. Remember that the equal sign is where it separates into two parts, the left side and the right side. I'm just going to draw my line like I did over here. I'm going to add straight down. 4 plus 12 is 16. I'm going to bring down that equal sign. Here's my x, and negative 12 plus 12 is equal to 0. So I'm just going to cancel that out. So there's my answer, and I'm just going to circle it. Now I can go back and check my answer by plugging that 16 back into x. Is 16 take away 12 4? Yes, it is. Couple more examples. Just viewing again with that answer being on the left side. X subtract 13. Here's my variable again. I am subtracting 13, so I want to do the opposite of that. That would be adding 13. So I'm going to add 13 to the right side and 13 to the left side. Draw my line. 16 plus 13 is 29. And negative 13 plus 13 is 0. So my answer is 29. Now if I want to check that, I'm just going to go back in and fill in 29 for x right there. Take away 13. And if you wanted to like write it so that you can like do your math like this, that is correct. So I know I'm right. Here's our last example. If you haven't spotted the variable yet, it's right there, it's x. We're taking away 7, so we want to do the opposite of that. I'm going to add 7 to the left side and to the right side. These cancel and equal 0, and I get x is equal to 28. Okay, so this is just an introduction to one-step equations. Like I mentioned, they do take a little bit of practice time, and you definitely want to be using a notebook and showing all your work like I did here. If you have any questions, let me know. But I think I will let you practice those a little bit on your tab software before I introduce two-step equations. All right, good luck, and let me know if you have any questions.